Okay, can you hear my voice and see my screen?
Yes, perfect. Go ahead, please.
Okay. And dear experts, I am Yajie from Huazhong University of Science and Technology. It's my honor to report to you my research work on effect of calcium sources on the biomineralization of tailings. I will report to you from the following four aspects. We know that tailings as industrial solid waste, whose gain size is small, the comprehensive utilization is low, and the management is difficult. The long-term storage even leads to the occurrence of major geological disasters. At present, it used for gold filling. The slurry used in the gold filling technology is the whole tailings as aggregate, which is evenly mixed with cement and water, and then transported to the underground gold for filling. The cement is involved in the cementing filling. It may be lost, increasing the segregation, which will decrease the quality of the filling. Furthermore, cement is a high energy consumption and high emission material, while changing the pH of the underground environment. Now, a kind of soil improvement technology, MICP, has emerged. Its principle is to use urease producing bacteria to hydrolyze urea to induce the formation of calcium carbonate crystal with filling and cementing under the condition of calcium salts to cement the loose soil into a hole. This process is simple, efficient, and friendly to the environment. Therefore, MICP was used in this study to conduct two series of tests, including solution test and sand clone test, to explore the influence of calcium sources on the biomineralization effect of tailings. The first one is solution test, whose content is to analyze the biomineralization process under different calcium sources to determine calcium ions concentration and the pH value of the solution at different time intervals to explore the influence of calcium sources on the process. The experimental scheme is shown in the table. As we can see from the picture of the treatment solution at different time points, in the solution test, 3 kinds of solution of calcium salts mixed with bacteria and water to produce white flux, which precipitate at the bottom of the breaker as time went by. The results show that the change of the 3 calcium sources of pH changes with time, is first rising and then decreasing and then stabilizing. According to the analysis of MICP principle, carbonic acid and anomia are generated after urea hydrolysis. The hydroxide ion leads to a shortened rise in pH, and the hydroxide ion of 2-stamp carbonate leads to a decrease in pH. The 2 ions combine to form calcium carbonate precipitate when the pH is stable. And we can see calcium ions decrease over time. The reason is that carbonate ion form the hydroxide of the second stamp of carbonic acid, and calcium ions form calcium carbonate precipitates. So calcium ions are conditionally consumed and generally reduced. And we can see calcium chloride decrease the fast, and the calcium acetate decrease the slowest. After that, the mineralized precipitate products were analyzed by XRD. We can see that calcite and waterate induced by waterate exist in calcium carbonate crystals induced by calcite, chloride, and calcium nitrate, while only waterate exists in acetate. In calcium chloride and calcium nitrate sample, the induced calcium carbonate crystals are mainly calcite. By comparing the two, we can see the calcium chloride calcite is higher than this. That is, the crystallinity is better. The second is tailings clone test. The concept is to use the biocementing treatment solution by 3 kinds of calcium sources to cement the tailings and to study the influence of calcium sources on the strength growth law of the biocemented tailings. Samples were divided into 3 groups according to the type of calcium sources. The samples of each group were treated for 2, 4, and 6 times. The samples were in triplicate for all the tested conditions. The results show that calcium carbonate content and unconfined comprehensive strength are both increased with number of treatments under different calcium sources. From this picture, we can see in terms of calcium carbonate production, the tailings clone with calcium nitrate sample produce the least calcium carbonate content, and calcium sample have the highest calcium carbonate content and the best cementing effect. As for strength improvement ability under the same calcium carbonate content condition, calcium acetate sample have the lowest strength. Calcium chloride has the highest strength and the best cementing effect. The XRD answers of the previous solution has shown calcium chloride has more calcite and its crystallinity is better than that of waterite. So in this, it shows good cementing effects on the micro level. SEM shows the cementing product of the calcium chloride samples are the calcite crystals with cluster of rhombic. Calcite nitrate sample product are calcite and waterite of different sizes. Calcite acetate samples product waterite crystals. Finally, we can see from this research in the solution test, the mineralization rate of calcium chloride is the fast, and the induced crystals are mainly calcite. Calcite acetate are the slowest, and the induced crystals are mainly waterite. From sand clone test, we know there is a positive correlation between the comprehensive strength and calcium carbonate content under different calcium source conditions. Although calcium carbonate content of the calcium acetate samples are the highest, the cementing effect of calcium acetate sample are the worst in terms of the strength improvement, and the cementation effect of calcium chloride samples are the best. So that's all of my presentation. Thank you very much.